Hello everyone and welcome to the next subtopic of the limit of a function, which is one-sided limits. So in here, basically we're going to specifically talk about the two sides of limits. If you recall, when we are asked to find the limit, we evaluate it by tabular form. First, we look at the left-hand side. Okay, we substitute x values to a given function. And of course, these x values are closer to the given input of the function, but from the left, right? So we exactly do the same thing for the right-hand side. Okay? So now you see, we compared the left and the right. And if these sides approach to the same value, then we can say that the limit exists. Otherwise, the limit will not exist. So in here, we're going to specifically talk about the left-hand side and right-hand side. Like, we need to know what makes it not equal to each other. All right? Or basically, it's like, okay, maybe left-hand side and right-hand side are not the same to each other, but I'm still curious. Like, what makes it not equal? And at the same time, what value that they are approaching? You get me? So we need to be more specific. Like, for example, from the left, if left is not the same from the right, what value is it approaching to? And same thing to the right, what value is it also approaching to, and why they're not even the same? Hence the topic one-sided limits. So limit has two sides. The left-hand side, or in other words, limit from the left, and the right-hand side, which is the limit from the right. So take a look at this one. Limit from the left. So you see this one, all right? The limit of, wait, let me just fix my handwriting. Hold on. The limit of f of x, and then as x approaches a, and then it has a negative sign, then you have the value. So when you have a negative sign as the exponent, or basically it's on the top right of the a, or the input rather, it implies that you're approaching a from the left. Okay, so that means your a here is less than your x here is less than a. So from the left going to the a. Okay, so that is limit from the left. On the other hand, when we say limit of the function as x approaches a, but the sign is positive instead, it implies that you have the x values that approach a, but from the right. So from the right, going to a. So this is x greater than a. All right. So if you see a negative sign in your input, that means it's limit from the left. Okay. Then here on an input that has a positive sign, like this one, it means it's a limit from the right. Okay. So let's try to apply it here. Okay. You have this one. Now let's find the what do you call this one? The given what do you call this one? Yeah, basically let's find this. Okay, let's find this. Okay. So let me just zoom in. All right, there we go. So you have a function f that is x squared minus 2x plus 1 all over x minus 1. So let's find the limit of function f of x. As x approaches 1, then it has a negative sign here. So meaning it's the limit from the left. So it's a left-hand side basically. So we will try, we will use tabular form. Don't worry guys. After the discussion about the limit of a function, I think the next topic we're going to talk about is the limit loss. Okay, like basic limit loss. I, I guess. So in that, you do not need to use tabular form and whatnot. You get me? But in this case, you need to get the idea of it first. Okay. So let's substitute x values that are closer to 1 from the left. So let's try 0.9. right? So if you substitute 0.9 in that given, so you will have 0.9 minus 1, you will have negative 0.1, right? Negative 0.1. Now let's make it even closer, like 0.99. So we have 0.99. So wait, hold on. You will have negative 0.01. Okay? So let's make it even closer to 1. Like, let's just say 0.9999. Much better. Alright? So this would be 0.9. Oh, wait. Hold on. I'm using calculator. So 0.99. Okay. 99. Then, where was I? There you go. So you will have negative 0.0001. So as our x values approaches to 1 from the left, you will have these results. And these results approach to exactly what? They are approaching to, what do you think is the result here? It's approaching to 0, right? So therefore, the answer here is 0. It's 0. Now, how about from the right? Going from the right. Right, yeah, yeah. How about from the right? So we will substitute x values that are closer to the right. I mean, no, x values that are closer to a, but from the right. So let's try 1.1. Right, 1.1. Okay. So 1.1. So 1.1 squared minus 2 times 1.1 plus 1. 1.1 minus 1. So this is 0.1. Okay. I see the pattern here already. So substitute 1. Oh, no, 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 no. It's 0.1. So 1.01, you will have 0.01. Okay? So let's make it even closer. 0.001, you will have 0.0001. So as our x values approaches 1 from the right, you have these results. And these results approaches to 0. So it's 0. Now, if you're going to take a look closely, both of them approach to the same value, right? It's 0. Therefore, your answer here is 0. That's it. Okay? That's it. Mm. So the limit of f of x as x approaches 1 is 0 because two sides approach to 0. Now, how about this one though? Okay? So let's try this one. Now, let's start from the left, which is this one because we have a negative sign here. So let's start from that. So x f of, oh no, f of x. All right. So let's start with what are negative 0. No, wait, serious? Yeah, negative 0.1. There you go. If you're wondering what I'm doing, I'm actually solving this one. Okay. And in here, it's about limit from the left because you can clearly see the negative sign. And you see, when we say the limit from the left, it implies that we're going to have x values approaches to 0 from the left. So we're going to have negative 0.1, okay? Because that's the closest value to the 0 from the left. So substitute negative 0.1 in this equation, you will have 9.9. You will have 9.9. Okay? Now, let's make it even closer to the 0. Okay? So, let's just say I will substitute negative 0.01. The answer here is 99.99. Alright, let's actually make it even more closer. Alright, let's try negative 0.0001. wait, 0, 1. Okay, let's try that. Wait. So let's say 0, 0, 1. All right, let's take a look. So it's 9999 point 999 and 9. So you see, as our x values approach to 0 from the left, we have these results, and these results do not approach to one value. Rather, it's increasing from 9.9, 99.9, 9999. And if we even try to substitute this one, I I expect that it would be more than thousands. It could be 100,000, it could be a million. So with that, it's actually increasing positively. So it's going infinite, right? Positive infinite, right? It's going infinite. Now, how about this one on the right? Approaching the input or 0, but from the right. It's from the right. All right. So let's try 0 0.1. Okay. I think the answer would be the same, but the signs would differ. But let's take a look. I could be wrong. 0 0.1 squared minus 1 all over 0 0.1. Okay, I'm right actually. So you will have negative 9.9. So if I'm going to substitute 0.01 here, that would be negative 99.99. And if I would substitute 0.0001, I will have negative 9999.9999, which is almost the same as the from the left, but the difference is the sign. So as our x values approaches 0, we have these results, and these results do not approach to a single value, just like from the limit from the left, but instead it's what? It is decreasing. The value is actually decreasing. Okay? Because here, negative, then we have another value that's not even close to negative 9.9. But the numbers are increasingly large. But since it has a negative sign, so it means it's decreasing. So the values are decreasing. Do you get my point, guys? Because uh, negative 1 is greater than negative 1,000. Okay? But 1,000 is less than, 1 is less than 1,000. You see the difference here? You see the difference between the two? Okay, that's actually basic math, guys. So, uh, if if you're going to compare a small negative number to a larger negative number, that means that smaller negative number is greater than the uh, largest negative number. Okay? So as you can see, if we substitute 0.00000001, you will have a large negative answer. So meaning it's decreasing. The values keep on decreasing and decreasing. So it's negative infinity. And now what would be your answer here? Since both of them are not the same, it implies that the limit does not exist. Because you see, from the left, it approaching increasing way. So it's, yeah, actually, yeah, it's increasing because when you say positive infinity, it's going upward. It implies that it's increasing. But if it's negative, it's decreasing, going down and down and down. So both of them are not the same. So it does not exist. So what have we learned so far? So far, okay, we need to make two sides the same. Okay, I mean, we need to make two sides approaching to the same value. All right. Sorry if I keep looking up because I was actually looking at my clock. Anyways, so here for the limit of a function to exist, we have the limit from the left equal to the limit from the right equal to the limit. In other words, to put it this way, the limit from the left and the limit from the right, they should be equal to each other. Okay? Both of them should approach to one value. Otherwise, the limit will not exist. Let me give you some examples, but more on graphing. Okay, you see this one? That's algebraically, I mean, they are problems, algebraically speaking, but how about we try this one? Let's try this one. Okay, so let's find the limit of a function as x approaches 3 from the left. So let me use different color here. Let me just use red. Okay, so from the left. Okay, so 3 is here, right? 3 is here. So we're going to approach values. Yeah, x values closer to 3, but from the left. So start with 2. So if you're going to approach 2, I mean, start with 2, you have the value of 0. How about midway? Let's just say 2.5, because this is 2.5. So you are closely approaching to 1. You're closely approaching to 1 here. How about, let's just say, assume that this is 2.75. Okay. So if this is 2.75, then your y value, it approaches to closer to 1.5 or midway to 1 and 2. Okay. So what if we get even closer and closer and closer to 3? Let's just say here. All right, let's just say here, like this point. Okay, like at this point, okay, it's actually here. All right. So your y value is getting closer to the 2. It gets closer to 2. All right. So that means as we approach x values to 3 from the left, it approaches to 2. Okay. And yeah, that's it. All right. That's it. Now, how about from the right? All right. From the right. Let's just say we try green. Like dark green. Maybe lavender. Or no, let's do pink. Much better. So here, let's just say we start from here, midway to 3 and 4. So 3 and 4, that would be here actually. Okay, that would be here. So your y value is here, which is, I do believe, closer to 3. Right? So how about, let's just say this is, for example, 3.25. Right? This is 3.25. So if this is 3.25, so wait, it's closely approaching to midway to ano to 2. Okay, but if we let closer to 3, okay, like for example like this, like that, it's whoa, okay, so it's getting closer to 2. So that means as we let our x values approaches to 3 from the right, it also approaches to 2. So what is now our answer here in this function? Okay, wait. So in this function, the limit of f of x as x approaches 3 is 2. Because two sides approach to 2, so therefore, to conclude, the answer is 2. That's it. All right? Now, how about this one? All right, this one. The limit of f of x as x approaches 2 from the left. So let me just use this color instead. So if I put 1 here, so 1 would be here. But let's just say 1.5 midway to uh 1 and 2. So it's actually here, right? It's here. Which is closer to negative 1. Right? It's closer to negative 1. Let's just say 1.75. If this is 1.75, okay, you are actually exceeding further negative 1. So it's actually midway to negative 1 and 0. But if we get closer to 2, just like this, it gets to the 0. So therefore, as the x approaches to 2 from the left, they're approaching to 0. Okay? Alright, so we're good to go. Now, how about from the right? Okay, from the right. So let's just start with 3. Okay, let me just use different color here. Uh, let's go along. Yeah, let's do pink. All right. No. Since we have a pink color here, let's just do red. Okay. So let's try 3. 3, is here. So that means it is approaching to, I mean, it is actually 1. Okay. Now, how about midway? Midway to 2 and 3. So that would be 2.5. So here. So this one would be getting closer to getting closer to 0.5. So let's make it even closer. So closer to 0.25 or midway to 0 and 1, which is 0.5. But if we let x closer to 2, so let's just say it's here and it's here. It's actually closer to 0. Right? It's actually closer to 0. So that means as our x values approaches to 2 from the right, it also approaches 0. So now what would be our answer here? The limit of f of x as x approaches to, the answer is 0 because two sides approaches to 0. Now, how about this one? Okay. By the way, if you see a white part here, it's a hole, by the way. Like, it's a hole. Oh, wait. No, no, no. Wait, guys. I was wrong. Wait, wait. For a while. Let me insert a circle here because I would like to draw a hole. And you remember that a hole represents what? A hole represents what? Whole is basically undefined. Okay? Undefined. But if it's shaded, it is defined, just like this one. Right? Forgive me if this is how I draw circles or holes because I'm not using a PowerPoint presentation anymore. So I cannot have a circle that is how to say this? That is how to say this? That has a fill color, basically. You know. So yeah. But at least I give you the idea that if there's a hole here, that means it's undefined. But if it's shaded, it is defined. All right. Before, when we discuss the graphing, the hole something, right? There's a white color. Yeah, right. But if it's this one, it also states that it is no, it is also a hole, basically. So what I'm trying to point out is that uh, if you see a hole, it's undefined. All right. So it's a hole, it's not shaded. Okay. If it's shaded, that is defined. I that will be all. So I think yeah, that's all. Okay, that's all. I'm making it complicated, but yeah, let's find the limit of function f of x as x approaches 1 from the left. So let's just say we start from the left, okay, which is 0. 0 approaches, no, it's actually going to an asymptotic line. Basically, maybe it approaches something to negative infinity. Okay? So how about midway to 0 and 1, which is 0.5? So which is this one. So that means your value would be closer to 0. So if we get closer to 1, we get closer to 0. And there we go. So as our x value approaches 1 from the left, the answer would be 0. Okay, the answer would be 0. Now, how about if it's, how about if it's from the right? So from the right, let's just say, let's start with 2. 2 is going further and further. So let's just say, here. All right, let's just say this is 1.25. So if that's the case, then it's actually approaching to midway 1 and 2, so closer to closer to 1.5. So if we let x values closer to 1, wait, let's make, all right, there we go, straight line. So it's get closer to 1. So if we get closer to 1 even more, like for this, for example, it gets closer to the 1. So that means as our x values approaches 1 from the right, the answer is 1. So what would be the answer here? Since two sides approach in different numbers, so the answer here would be what? D and E. Right, it's D and E. because two sides do not approach in one the same value. All right? And that will be all, guys. All right? So expect that I'm going to have a practice video for this one so that we can even master the lessons here. Then after that, we're going to discuss the limit laws, right? And yeah, I think that will be all, guys. So I hope you have learned today. See you soon.